Welcome back. In this lecture, we would consider how the battery resistance can be correlated to provide information on the state of health of the battery. Battery resist can be estimated via a couple of methods. One of the dominant method is via electrochemical impedance spectroscopy. The other method, especially for estimating the ohmic resistance of a battery, is via the current interruption electrochemical techniques. All these things have been covered in our previous lectures, so please take a look at these lectures to understand them better. We will just use a particular experiment to illustrate what we are trying to convey. In this pulse power test, what we do is that we charge the battery, and this is the charging current, right? So this is the axis for the charging current is here, and this is the discharging current. Again, the axis is provided here, corresponding to this current interruption, right? So here suddenly the current is increased and then stays a constant, and then current is brought down to zero, remains zero, and in the opposite direction. This is charging, this is discharging. So corresponding to this current interruption, you have a potential change. So as soon as you increase the current, more or less at the same time, there is an increase in a voltage, and then there is another phase when you keep this current the constant. There's a slow variation in voltage, and then when the current is brought down, there is a rapid decrease in potential. All right. So in the previous lectures, especially when in this lecture on current interruption technique, we had argued why this provides information about the ohmic resistance. Okay, so as this is increased, the potential changes. So one can calculate the ohmic resistance of the cell via this formula, change in potential for change in current, right? So as this current changes, that goes here, and the potential changes goes here. So we are not really bothered about these change in potential. For quantifying the ohmic resistance, only this change matters. We are assuming the ohmic loss to be the dominant potential loss. So these are all ohmically limited batteries. So the V of the battery can be written as potential, open circuit potential of the battery minus I R, where R resistance is computed from this formula. Okay, right? Why is this important? So now that we know the resistance, why is this important? In an earlier lecture, for example, in this lecture, estimate of the maximum power from a fuel cell, we have derived what is the current at maximum power and a formula for maximum power. So if you go into this lecture, the basis for these two expressions for power and current at maximum power would be clear. So this is an approximation. So in this approximation, the current at maximum power is related to the ohmic resistance of the cell. And this is an inherent property of the cell chemistry. Once the chemistry is fixed, this cannot be changed. So power, maximum power, is also approximated via this expression, wherein this cannot change once you fix the battery chemistry. What may change is the ohmic resistance of the cell. So what do these expressions convey. When you keep charging and discharging the battery, as the cycle increases, okay, number of cycles increases, the resistance of the battery keeps increasing, right? So corresponding to increase in resistance, there is a decrease in maximum current that can be obtained from a battery, and also the maximum power that can be obtained from a battery. Okay, there's an inverse correlation between the resistance of the cell and to the power and current at maximum power. So how do you define state of health? State of health is the present capacity of the battery divided by the design capacity of the battery. That is, when in the first cycle, let's say the battery comes out of the factory, so there is a design capacity. It has been tested and calibrated to this capacity, but as you keep charging and discharging the battery, the capacity decreases. So what is a good measure of state of health are these two quantities, current at maximum power and the maximum power, because these two quantities are correlated with the resistance of the battery here and here. What is a good measure of state of health is the resistance of a battery. So that is the logic. Okay, so these provide estimates of maximum current at maximum power and maximum power, and resistance of the battery, that is the ohmic resistance of the battery, provides a good measure of state of health. And this particular technique helps you get a quantification on the resistance of the battery. In the next brief lecture, we will introduce what is called the battery management system, which is also quite important in the practical application of batteries. Thank you.